joining us. All right, hello everyone. This is Vince Vitro. Next again. I hope you guys had a good week last week because we were off on spring break. And welcome back. Totally shifted gears. We're going to talk a little bit about debugging several different codes, serial, MPI, OpenE codes, using TotalView and DDT. Those are two of the debuggers we have. So we're going to talk a little bit about why a debugger and do a little bit of examples. So this will not be a long presentation, mostly hands-on, quote unquote, or my hands-on, your hands. Why use a debugger? Well, like most of us, or a lot of us, when we were coming through our first parallel experience, we were print statement junkies. Often when we didn't have access to, wasn't mature enough to use a parallel debugger. And sometimes that could be a problem. Sometimes you really had to spend some iterative time on your code, coming up with print statements that didn't give you too much information or too little. And so being able to look at variables and change sort of what you see on the fly is extremely useful. The other thing that's interesting is in the case of parallel programming, and I'm gonna posit this as primarily OpenMP. There's no guarantee that what you see printed on the screen is actually representative of what's happened. Often what you have is the buffer. Even if you flush the buffer every time, the OS has to choose which thread buffer to flush out the screen first. And to do that, you may have things come out of order than they're executing in, and may actually hide the real problem. You may have a real problem that is showing through your print statement. And that often happens when you have executions all having to join back together and output through one mechanism. So debuggers are out there. Well, there's lots and lots. These are the most common ones. These are the ones that we use at NIT. Have your GNU, GDB, and BDB. Those are free, open source debuggers. I get difference command line versus a GUI. One of them you type, you have to know all the commands. Print this variable, print that. Breakpoint set, things like that. The GUI version, DDD for instance, you would type those things, and so you don't necessarily have to. The take is long on knowing commands. Now the downside is you're tunneling X. So if you're working from a remote system with a bad connection on a GUI, you're going to skip slowdown. The Intel version thereof, IDD and IDDC, are again the same thing, but they come with the Intel compilers, which of course we have on all systems. We have Roadway TotalView and Alinea AT. Both of those are licensed, so those are vendors that we have to pay money to have those licenses. Of course, there are like CRAPAT and other different performance analysis tools, electric fence, things like that. But those are very specific. Electric fence is a memory debugging tool. Algrind is a memory debugging tool. You've got some of the CRAPAT, which is more performance analysis. So these are things that will either give you very specific problems with memory only, and even that, if you've ever used Algrind or electric fence, you know that it will often give you more information than you can possibly stomach. I have a lot of these. This may not be a problem. This pointer is referencing something that hasn't been allocated yet, which could be okay, but we just want to let you know. And 100 of those is one useful method. So those are tools that are very specialized, so I'm not going to go into that. So your environment, anytime that you're using one of these graphical debuggers, specifically TotalView and DDT that are graphical, I want to make sure that when you SSH into the machine, as well as when you submit your compute job interactively, or not, well, it actually has to be interactively, that you use a -capital X. -capital X is what gives you the ability to forward the X windows to your local machine. Right. When you use TotalView, you do module load TotalView or module load Alinea, and then you run TotalView or DDT, and you work from within the GUI. Now, there are options to run these from command line, but again, this is a short tutorial. When you have the basic concept of how to use it, if you have something that you want to be able to run from the command line and go back and look at later, you can also do that. You can set up Totalview to pull up at a certain point during the NPI execution of the program. I had several different codes here. Serial code, an NPI code, and some OpenMP code. Okay? And then that was it. So we'll go back to the presentation shortly. We're going to go to the next one, but right now we'll just focus on going through. I'm going to open up a terminal here, and I'm going to log into Beacon. Just because I feel like there'll probably be less on there. Now, I will point out, I'm not going to talk about mic debugging. Linear and Totalview are capable of mic debugging, and there are tutorials on the Beacon documentation side about how to use them for mic debugging. I'm not going to go into mic debugging today. That's another level of, we could do debugging tutorials for a whole year and still not get everything. So just want to give you guys some context. Log in. Didn't like that. A little finger. Well, you know what? Maybe I'm going to need it. Hey, dummy, going to say. It isn't a PM, but I should still be able to get into the log. But we'll try that. Okay, so it was just hating on me. Let me get to crack and then over to Beacon. Sometimes we'll need that to reset the pin. There we go. Let me in. Anyway, cool. Needed to update my OCP. So now that we're on a login node of Beacon, all right, I'm going to do. By the way, if you, yes, sorry, I always do that. Apparently, and so I just just real briefly, this is not going to take any time at all. But, you don't need to be able to see it particularly well. What we'll do is copy files that you will download it with this presentation. Right? I'm going to take over to my Luster directory. Just forget. Actually, over to my home directory. And there now we should have master directory, right? A directory called code. Several of these different. So First, let's just look at what serial error looks like. All right, serial is a simple algorithm. This is using the arctan, integrating it from 0 to 1 to calculate pi, which, interestingly enough, was the way that was the first algorithm that von Neumann ran on the ENIAC computer practice going on last night. So I thought that was pretty cool. Feel standing on the shoulders of giants. All right, so this is a very simple algorithm. Okay, there's an error in here. There's a significant error in here, actually. So let's see if we can't figure it out. Let's do this. Let's do a module load total. All right, and then we'll view. All right, and it opens you up a window. And what we do is we want to debug a new program. This is not a parallel program in any way, shape, or form, so no need. So what we do is we need to show which file we're interested in. Right? So we know we want to do luster. The intro code. All right, doesn't exist yet, and of course that's because I'm a fool. I didn't compare. All right, so ICC. I'll do. All right, now we'll do total view again. Now that we have beautiful. Get. You're doing a really great job of showing you how not to do this. All right, I didn't compile it with debug symbol, so it'd be great. It would totally run in the debugger. Takes a lot. All right. So new program, as we said, we'll do else. We need serial error. All right, we're going to debug it on our local machine, or on our just been logged in to. We can do debugging. We can do memory debugging, CUDA memory checking. There's lots of different options. Obviously, we don't need any of these because this is a very serial, simple. All right, so we're at the session. All right, so we're going to hunt for just a second. That's what I was about to do. So I was going to do module list. So I'm using TotalView 8T. Let's do module event. Remember TotalView. TotalView 8.12.01. That's the one. That one we have a license for. The other was a beta version. So module swap TotalView /8T.3.0-1. This. Now we should run it without a problem. So we're this again. Run serial. Next. Start session. Okay. This is a problem. So it's complete disaster. It won't matter because the license server is down. So if that doesn't work, guys, we'll just use DDT. It's okay. So so it's no big deal. So module unload total view is it would be software folks and found out why we didn't get an updated license, why the license server is not running. All right. So now we'll try this again. Oh, look, we got another one. This DDT, when I think about DDTs, it tells us right off the bat. Hey, that we do. So obviously, this license server is. We're going to run and debug a program. No too stupid. So we want to go to my server directory. Honey, this is we don't have anything special we need to do. We just give it the application and we tell it to run. It connects the process, and there you go. You see your source code. We compiled it with the debug flag. And what we do is we can just run it. Now, this compile, interestingly enough, all right, this is terminated. Would you like to restart from the beginning? No, that means it ran and finished. The approximation for pi, 3.1603. All right, last pi was 3.141592. So that's, I wonder what might be wrong. All right. When we look at the code, there are only a couple of things that are occurring. Okay. We have an x that's being calculated, an x value, and they're using that x value to create a y value, or the height of the little Riemann block to sum those up. We're just summing to a function, 4 plus x squared, which last time I checked is the analytic derivative of our tangent. Right? The analytic derivative of our tangent. So the one thing that seems suspect to me is this x value right here. So let's put a breakpoint there. All right. What we want to see is what the x value is calculated. So I'm going to set point. All right. To have a left mouse button. So breakpoint. Okay. This breakpoint. I'll do. Folder's working fine. Well, all right. So I would point here, and normally I would right-click it and say set breakpoint, but it's taking my one-button mouse on. That's why graphical things are difficult. Doggone it. So, go to line 9. Will you chance? Set a break. Right. So here's what we can do instead. All right, we want to run. Now, let me set a breakpoint. Will you let me now? Hey, here we go. Add breakpoint. Cool. Now we'll let me do it. I got a breakpoint here, and once I got a breakpoint, what it's going to do is, as it goes into the code, I hit play, and it's going to go, I need to stop here. This is where the stuff of interest comes in. So, do I want to continue? Do I want to pause? Well, I want to pause, and I want to step in. Right? Notice here, there's step into, step over, step out. We want to step into, okay? So, I got it. I was able to figure it out. So, thank you for going and getting another one. All right, so step in, I want you to look at something. Right? And first time in, right, our value for sum, which is 0, which is what it should be, right? And then we got our first x value of negative 2.5. Something's wrong. All right, getting this 0 to 1. Keyboard. Okay, cool. Thanks. So, you notice here the sum is 0, but my variable x is negative 2.5. What were our limits of integration? 0, right? So my first x value is outside of my limits of integration, which means this is wrong with the way I'm calculating x. Okay, now, let's set this up. That's how I set it up to break. All right, set up to break there. So I'm going to quit real quick. All right, say I don't need to finish. And I want you to look at, let's look at correct. Actually, I'll zero correct. This would be, if you guys are doing these examples on your own, and we'll go back and see if you found the right error, this would be a good way to do it. Just the file and see what got changed. All right, so in serial correct, I have I plus 1 minus 0.5, and you have I minus 0.5. Now, if I do I plus 1 minus 0.5, I is 0, I get 0.5. Is that within my limits of integration? 0. Oh, yeah, definitely. So that would be the correct formula. So let's just, out of sheer curiosity, serial correct. Sorry. Serial correct. Right answer based on that bug. Now imagine I went back and just changed that. That's, you know, serial correct. I run it with 3.141559. That's the answer. You can see that is the kind of error where you could have print statemented over and over and over again, and unless you did a print statement with the x value and the y value at each x value, you wouldn't necessarily notice there was a problem. Even worse, if you were just to have looked at the y value, at the sum value, x is squared, so what would happen to that negative? It would go away. So you wouldn't even notice the error propagated anywhere. Only you would have found that error is to dive in and go value by value through x and see if those values make any sense whatsoever. I am going to go in here and we are going to do, there is an MPI one, just since we're running short on time. I'm going to talk about what the error I would have found was in there. Did MPI.c and error.c. All right, and you'll notice here that the error is I equals 0. I have starting into C, and here I just go ahead and set that starting into C. So let's take a look at that. Error.c. This is the same exact problem, except that what I'm doing is I'm split out in a distributed memory process. I'm having the processor do its own chunk of the sum, and then it do an all reduce here at the bottom. The start information, right? This is going to tell me what I value I want to start at. And that change based on each process. Okay. Now, unfortunately, I did not put I equals 0 above this start. I only want it to run this when I equals 0. Why do I only want to run this when I equals 0? Well, I'm incrementing start. So increment start, but I actually change this. Guess what? It sets it back to 1 number for proc. 2. It sets it back every single time it goes through. It ignores the incrementing. So what I would have looked at here is on the debugger I'd have gone through and I'd have pinged through start. And I looked at the value. You watched it grow. manually, and then all of a sudden it would just drop back to something completely different. You don't want that. Otherwise, what you're doing is you're basically doing the same little section of the area under the curve on each processor instead of distribute the curve up amongst all the processors. Okay. All right. Last one. This one's a good one. All right. I'm going to do a diff of OMP underscore star. OMP correct dot C and OMP underscore ER. Yeah, it's just not all. All right, dot C. So what difference here, just so we can talk this more quickly, all right? In this particular case, the difference between the correct and the errant, okay, and the errant one, you know, here I'm sharing X, okay? That same exact, so OMP correct, all right, it's that same algorithm, okay, I did, when I screwed it up, I put an X right here, share X. Now, this X that's being computed is being computed for each X value along that curve, and is being per thread, correct? So if I share that, what's going to happen every time a thread comes into the section? It's going to run. So you're going to get totally erratic behavior. You get the right answer 1 out of a bajillion times, right? And that stinks because you think you did everything right, but as it turns out, you find out you just happen to luck out and miss the rate. Okay. So let's see how this one goes through debugging, and then that'll be the end of our discussion for today. So IC minus G MP underscore error underscore error dot C. Gotta give it minus open MP too, don't I? To do minus open MP or not do anything. That's an interesting fact. If I do MP error like that, almost the right answer. 3.1594. Okay. Nothing too ridiculous. Now let me do this. Let me do export OMP threads equals 460. And then again, right? Notice that. So I changed the number of threads. Pi changes, not what you want. Okay? Right there should be an indication that you've got a race condition somewhere. Right? I had a professor in graduate school that the worst thing is an answer that looks almost right. Because that means you got some bug there that's going to be harder than the get-go. Now that's where debug is. So let me roughly run this through DDT, and then we will watch my so let's propagate the way through. Sure. Okay. A little bit. And do module load Omnia. DDT. Here, we're going to do a new program. We do not have to select a new parallel program. It's going, it's asking us, yeah, what do you do? So I'm just going to run and debug a program, period. All right, this code is going to be, we know it's called OMP error. Now, there's one extra thing, though. We need to give it a number of threads. All right, let's just say 8. That's one thread per core bridge. Okay. And we could also put in environment variables. These particular environment variables are being passed over from a previous code that I worked on, where these passed over to hard data restart directory. A code and a number of threads. I click run. It says not appear to be an OpenMP program. And I'm going, no, it's an OpenMP program. That's okay. So sometimes debuggers can be a little too smart for their own. So if this particular program, all right, what I'm going to do is I'm going to set, I love having a right-click button. Look how much easier that was. All right. So I set a breakpoint at X, all right, and I'm going to set a breakpoint at X because that's going to show us some interesting stuff, and it will stop at the part we're really kind of confused about. All right, so here you can I step of X. We can which thread we want to look at, right? Threads. Of X. Now this is garbage because it's initialized at this point. Right? It's total garbage. Step in. So now I have threads. A minute. I've stepped in, and for some reason, the value of X is still the same on every thread. Something kind of fishy here. All right, when you would start to see that it are, and so here we go. So first of all, you would start to notice correctly that if same on every thread, that's probably wrong. And if you did notice that, you have the option of doing just looking at a given single thread, right? And looking if the value is what you would expect it to be. So now X is 0.0175. Sorry. Now 0.25. All right, it should be changing that much in between iterations. Right? We're stepping incrementally across X by delta. Not have it going from 0.75 times 10 to the negative 6 all the way up to 2.25 in one iteration. That shouldn't happen. That's how that something fishy is going on. You look at this and you in your mind do the calculation, and then you look at the actual variable in memory and you go, oh, that is not it. So I know that was an incredibly short introduction to debugging. Hopefully, though, it will have introduced you to some basic tools and basic methodology for looking at OpenMP, looking at serial, looking at MPI. And I really do hope, since these are out there for your perusal, that you have a chance, you actually go in and do some examples and try to play around with it on your own. And these debuggers will do all kinds of amazing things, more than I ever could have dreamt of back in grad school. So, with that, I will go ahead and end my talk. And yes. Yes. In that case, if the total view on Dart or Kraken, that means the server on Beacon or Beacon is down, which it's not actually the license server that's down, but Beacon is not seeing the license server, so I'll fix that. And then the license was a demo license because it's a beta version. I just need to get that updated because they still haven't released the full version of that beta. Total view. Let me run any program. Anyway, sure. Oh, that's why. No, Barber. I'll just have to grab from my home directory. grab a component. It's crackable, but I might be able to do something. Yeah, it's just this thing. It's reading symbol. I know, but I just wanted to grab anything. Now it's doing its thing. That's a, yeah. This is another silly simple code. It's the same one we're looking at. It's the MPI. No, I've got them all over the place. Just the problems. So yeah, indeed, license fine on Darter, Kraken, Nautilus. So we'll get it sorted out. We'll get it sorted this. So it does work. That is good. And you will see that Totalview and DDT both do really good things. I really don't recommend one over the other. I think they're both very good. It's more just which one you have experienced most and preference. So, any questions for me from folks here in the room or folks on the web? Oh, they're proprietary. So, Totalview and DDT are both proprietary, but we have licenses for all of Nick on both. So if you use resource, you can use debuggers. So you get Any the new one? Oh yeah. Almost as good, or they're almost as good for for the basic thing that I just did. They're just as good. Printing a variable, stepping through code, they do just as good. I'm going to take DDT and Totalview a little bit high level. One is the interface is a little bit more easy to use. Is that you have things like reverse debugging, where what you do is you can actually, it's kind of, you play your code through, and you get to the point where it's doing something funky that you don't understand, and you can track. That is something you can't do with GDB. GDB just does forward debugging. You have to tell it, like, stop here, start looking here. So you have to be a little smarter, and you've got to at least have a clue where to look first, instead of these other ones where they actually let you run it until it blows up, and then walk backwards and see what kind of value you've got. Give you a better clue of where to go next as far as debugging. So they're mature, but for the basics of debugging, day to day, they will all give you exactly the same. Just a matter of use. Do they want yes. So and that now, well, okay. Caveat. Two MPI and OpenMP. DDB will single MPI process. You can't switch back and forth between that. Similarly to the OpenMP with GDB, it was the single thread, and then when it forks, you're just going to get the master thread, and when it's done, you go back to the single thread. So you basically, whereas there's no master process with MPI, you just pick one. In this case, there's all master process for OpenMP, and that's all we're going to be able to do with GDB. These pretty much the same thing. They're meant for serial debugging. Some slow additions of some of these parallel tools that we use, but major vendors in the market, they've got a pretty head start on GNU and Intel as far as the parallel tools. So sure. Yes. Like with that OpenMP one, I was actually having to move through all the threads. I could just bounce back and forth when I click the 1, 7, whatever. Yeah, with MPI processing. You can do that in both. That's just in both DDT and Totalview, that will work. What they do is they actually set up a daemon that runs each one of them separately and controls stuff from it. And it's a much smarter interface because, as we all know, running in parallel, you've got to be pretty picky about how you do that. You have to get the data from the right file. Collect is non-trivial. Good Debugging is very mature in both products. Totalview and DDT. In fact, I've given tutorials on both of these and other we can obey or whatever, and do a CUDA debugging part. As far as, in fact, I think you may have seen it. When I clicked it open, you actually had things like CUDA, enable CUDA memory checking and stuff like that. They're both, because they've been around for so long, CUDA's been really well in the market for 10 years. They've got pretty robust support for those compilers. And they also have Xeon Phi offload and native support. So they're, guess what you pay for kind of thing, right? You pay for it, but they're going to be able to support just about anything out there with time. All right, everybody. Don't forget to be here on Thursday, same time, same place. We'll be giving a tutorial on program optimization. Won't be, so you'll get a fresh face. But then I'll be back on April 8th to talk about I/O for file systems. And so be at all these if you can, and check them out, and let us know if you have any questions.